Okay, so here we have the two spreadsheet. That's the evolutionary data, K data, I call. And then we have the protein interaction network data. And in this case, it's basically the number of interactions per gene. So frequency is the number of interactions per gene. And ID is the ORF, open reading frame in the net spreadsheet. And then we have in the evolutionary data, we have Ka, Ks, Ka for amino acid change, Ks for change only at the DNA level, but not at the protein level. Where I've named that this column is also the systematic gene name for each genes. And our goal is to repeat Fresher figure 1, which is the Ka regression versus the degree, the number of gene interactions. But they are in two separate spreadsheets, and we cannot run linear regression, say run Ln Ka over frequency, since they are in two separate data frames. So basically, we want to transfer the frequency data into degree, basically, using the match function. And our goal is to move the frequency all the way here. Maybe change the color on my pen. Pen color blue. Okay.
So when you do the match, how you calling it degree in the K data set, you have to give it like a new name or?
No, you don't. Yeah, you can still call it frequency, but it's kind of confusing. But degree is more appropriate term. It was originally called frequency because that's a default output by the table command. The table function in R name everything frequency. Yeah. And so here I move it after I move it to evolution data. I want to do a regression. Degree is more like an appropriate term for this data. So now the question is, how do we merge the two data sets? And you can see the gene name are in different order. This one gene 2, gene 11, gene 9. And this one is in different order. How do we match? I mean, intuitively, let's work this one out. So gene 2 should be where? Gene 2 is here, right, in this row. So if I want to put a value here, I should go to the net data looking for gene 2 here.
So does it matter that you have more than one gene 2 in the net?
If that occurs, that will be a mistake in the net table, because there's only one gene 2. If you have two genes with the same systematic gene, then that must be a mistake. Yeah. So on gene 11, we goes. Oops, not here. It actually goes here. Sorry. That's gene 11. Gene 9. Gene 9 goes here. And gene 10 is here. Gene 13 is not there. It's not in the net second one. Gene 14 also doesn't exist there. And gene 21 is this one. Right. So basically, if we do a manual merge of the two spreadsheets, we have to put those values, match them, and then match the row by row manually. And then we look at the gene 2 says, well, gene 2 is in this row, and that's 1, 2, 3, 4, 5. This is the fifth row. That's the fifth row. Well, this is 1, 2, 3, that's 4, and 6, 7. So basically, we have to, if we match one, we have to put this one go to the fifth row. Gene 11, we go to the second row. Gene 9, we go to the seventh row. We have to put those numbers. put the frequency in different order by the matching order. And this is exactly what the matching function is doing. So we basically, let's say that we manually say match the rows in K data to the second data sheet net. By matching the gene names. So basically, what's the parameter we should write it in this match function? Again, we have to use the operating frame as our primary key to match the two spreadsheets. Right, we have K data. Oh, terrible writing, sorry. And $sign. OIF name. Sorry, I can't even read myself. Sorry. Net. Let me. Net. $sign. This one should be ID. Yeah, so the match function will basically do the manual matching here. Match the degree to match the operating frame here by rows to the net ID cycle in the net spreadsheet. And basically, this is what after matching function do. Yeah. After we match K data operating frame to net ID, this is what the result would be. And those rows will be matched. You need to remember this matching is not symmetrical. It's always match the first one to the second one. So what we getting is basically the matching position in the second spreadsheet, and then we say, well, which column do we want to move to the first spreadsheet? We want to move the frequency one. So, oops. Let me see. We want to. So we have to put this one. Basically, frequency is a column we want to move, and frequency in net and how do we call the column? We use a $sign there. And since the matching function, the entire matching function is return the positions, we also have to put it into a square bracket over there. And this will be the basically taking out the frequency and in the same order as in the the first spreadsheet. And we can then put those basically here to degree. That will be the first spreadsheet data. And then, but in R we basically say K data $sign degree. Right. DEGRE. Oh, terrible. Sorry. Still learn how to write with the mouse. But basically that's this does. Oops. I'm trying to show the last row, last line here. Yeah. Basically, this is what after the K data degree, if I assign it to K data degree and move from and all what this command does is merge the frequency from the net to the degree column in the first one, and based on the matching orders. That's what this command does. Oops.